This is paper 3, section 4, or video 4, for the mock exams. For this question, it's just a simple substitution. All you need to do is to put the value it tells us into the equation. The only thing we've got to look out for is the fact that the thing that we're substituting in is actually the thing that is the subject. We're not substituting in t. So if d is 3, I simply rewrite this. So it's 3 equals 6t cubed. I then need to try and work out the value of t, so in other words make t the subject. In order to do that, I would divide both sides by 6 to give me 3 over 6 is equal to t cubed. I'd probably at that point, just to make it a little bit easier, simplify the fraction, and then all I need to do is to work out the cube root of a half. So at that point I just pop it in the calculator and work out an answer. The next question is all to do with similar shapes. Two shapes are similar if they're the exact same shape, just one is an enlargement of the other. So the first thing we would need to do here is to actually work out the scale factor of the enlargement. To do that, we try and find sides that we know for both of the shapes. So it's not going to be these two sides because we're missing some values. It's going to be this one that we use. In order to work out the scale factor, simply take the size of the larger shape divided by the size of the smaller shape. It was 1.5, and that's the scale factor. So the bigger shape is just 1.5 times bigger than the smaller one. In order to use this, so for the first question, it says work out the length of the side PR. So that's this side here on the larger shape. So I take the corresponding side on the smaller one and times it by the scale factor, which in this case would give us 39 centimetres. For the second part of the question, it's asking us to work out the length on a the smaller shape. So for this one, we would actually take the corresponding side on the big shape, and because we're trying to find the one on the smaller, we would divide by the scale factor. So we do 45 divided by 1.5, which in this case gives us 30 centimetres. The next question again is another substitution question. Here it has given us this equation, so y is equal to 5 over x squared. The question is simply saying what happens to the value of y when x doubles. Now it's not given us a number to substitute in here, however we are fine just to pick a number, see what it does, and then we can use that to try and explain what is going to happen. So to make this as easy as possible, what I would do is say let's start with the value of x equals 1. I've just picked an arbitrary value, one easiest thing I can think of to substitute in. So here we would do y is equal to 5 over 1 squared. Well, that's just the same as 5 over 1. And 5 divided by 1 is just 5. So this is the value of y when x is 1. It says what happens when we double it. So if we now do x equals 2, the exact same idea, but substitute 2 in instead of the 1. So we get 5 over 2 squared. This is the same as 5 over 4. And again, pop it in your calculator if need to. This gives us 1.25. So by doubling the value of x, what has actually happened is that the value of y has got smaller. Now it might want to know by how much smaller. So all I would do to find out how much smaller it's got is I'd do a little 5 divided by 1.25 to show us that it's got 4 times smaller. So actually the process, the effect that doubling x has is that it's made it 4 times smaller for y. The next question is all about time and depth graphs. So here it's all to do with the fact that these vases are being filled with water. Now it says that they're filled at a constant rate. So that means that the water is coming out of the tap, hose or whatever it may be at the same amount every single second. So the first thing it's asking us is what is wrong with the graph? Well, the first thing that I notice is that there is no labelling or units on the y-axis. Same, if this is time along the bottom, I would expect to see some units there. So that's one problem with the graph. Second question, which container is the graph showing? Well, if you look here, this line here means that the depth of the vase, also the depth of the water in the vase, is increasing over time and then starts to slowly level off there. So that means that the depth is getting higher as time goes along, but then the depth starts to slow down, or the speed that the depth is getting more slows down. The vase that would show this would be C. Because it's got quite a narrow bottom, this means that the vase is going to fill up very quickly, and as we get to the top, the same amount of water is not going to have the same effect. So here we get vase C. Final part of the question is, what would the graph look like if we had to show for vase A? Now, because this is a perfectly vertical, perfectly straight vase, what I would expect is to see a constant change in terms of the depth. So the depth is just going to go up by a constant amount for the entire time that it's being filled. So you just get a perfectly straight line going through.